There is another resource that I use myself to choose graphic forms to encode data that I describe in my book, The Truthful Art. This is a hierarchy of methods of encoding. It's a hierarchy that was devised originally by several statisticians, William Cleveland, Robert McGill. It's a hierarchy that shows you how graphic forms are organized according to accuracy. Let me explain what I mean by explaining a little bit of the background of where this hierarchy comes from. First of all, I'm going to show you the hierarchy so you can see it. All right, so this is what Cleveland and McGill did. Back in the 80s, Cleveland and McGill did several experiments in which they encoded the exact same data set in multiple ways. Imagine that we have numbers such as 20, 40, 60, and so on and so forth. They encoded those numbers as a bar graph. They encoded those numbers as a bubble chart. They encoded those numbers as rectangles of different colors. I'm making up the details, but this is the gist of the story. And they showed each one of these representations of the same data to different groups of people, to ask them, for example, if this bar is representing 40, how much is this other bar representing, right? So you can put a question mark in there. They asked people to make an estimate of the size of this bar in comparison to this bar. And obviously people were very good at that. If you see this bar and you know that it represents 40, you can probably estimate that this other bar is close to 80. But then they did the same thing with bubbles. To another group of people, they said, you know, this bubble is representing 40. How much is this other bubble representing? And here, the estimate is a little bit harder. It is harder to see that this bubble over here is actually double the area of this other bubble over here. You can insert two bubbles of this area inside the area of the second circle. So people were less accurate in their estimates, right? And then they represented the data also with color shade, right? If this color that is dark, that is lighter, represents 40, how much is this darker color representing, right? And they discovered through this process and these experiments that it is possible to create a hierarchy of methods of encoding according to accuracy. The further up you go on this scale, the more accurate the judgments that you can make based on these graphics, and the further down you go, the less accurate the judgments that you can make. We can extract several techniques to choose graphic forms from this hierarchy. The lesson that I extract is that, for example, whenever I want to represent my data very accurately, and whenever I want people to see things very accurately, to compare things very accurately, or to see change over time very accurately, and so on and so forth, I go up in the scale. I go to graphic forms that are built onto using methods of encoding such as length, height, position, measured on common Cartesian scales, right? Such as, for example, the line chart, the bar chart, the scatter plot, the slope chart, and so on and so forth. All these graphics have in common that they are built on common scales, and at the same time that they use methods of encoding such as position, length, and height. These are the methods of encoding and the techniques of design that enable more accuracy. So when you want to see very accurately, it is better to go up in the scale. But that doesn't mean that the methods of encoding that are on the bottom half of the scale are useless, right? They can be really, really useful in certain circumstances, right? For example, when you want to give just an overview of the data, when you don't care that much about whether people can compare numbers very accurately, when we want to do just provide the big picture of the data, methods of encoding such as color hue, color shade, area, and so on and so forth may come in handy. I already showed you an example of the use of these methods of encoding. I'm going to show you just another one. This is a graphic that was published by the New York Times after the 2008 election in the United States. As you can see, the data is represented through several maps, some of them using bubble sizes, bubble areas, some other maps using color hues and color shades, right? Now, why did they use these methods of encoding in this particular case? Methods of encoding that don't enable a lot of accuracy, that belong to the bottom half of William Cleveland's and Robert McGill's scale? Because the purpose of this visualization is not to enable you to compare and rank Miami versus Austin, Texas versus Los Angeles versus San Francisco versus New York. The purpose of these graphics is not accuracy. It is to provide a big picture of the data, to give you the overview of the main patterns in the data. Democratic vote tends to concentrate on the coasts. It tends to concentrate also in urban areas. Republican vote tends to be a little bit more dispersed over more rural areas and the interior of the country. That's the overview of the data. So, going back to the idea of purpose, if the purpose of your visualization is to show at a very, very, very broad level the bird's eye view of the data, if that is the purpose of your visualization and to show the overall patterns in the data, these kinds of methods of encoding work really well. On the other hand, if the purpose of your visualization were to let people compare and rank county by county according to Republican vote or to Democratic vote, the map will not be the right solution. You will need to use other kind of graphic forms, such as a table paired with a bar graph or something like that, representing the percent of Republican vote or the percent of Democratic vote. Sometimes, particularly when you create interactive graphics, you can let the reader choose how to visualize the data. Show me the data on a map, show me the data on a bar chart. The map will show me the geographic patterns, the bar graph will let me compare the numbers more accurately. When you start using, for example, Flourish, which is the software tool that you are going to learn this week through the practical videos, you will notice that Flourish will let you visualize the same data several times and in multiple ways. And you can combine those charts and those maps into stories, which you can navigate through buttons. You can click on Next and see the data in another form, and then click on Next and see the data represented in a different way. So choice is another very important principle in data visualization when you have that luxury, particularly when you do, again, interactive graphics.